All right, guys, so we're going over the review sheet. So we're going to look at the first page here, problems 1 through 6. Now, in problems 1 through 6, it asks us to classify or name the triangles given their sides and angles, or its sides and angles and sides. So each one of these triangles should have two names, one for the angles, one for the sides. Now, if we look at number 1, well, the angles are 60, 50, and 70. Well, all three angles are would be acute. Do we know anything about the side lengths? Acute scalene triangle. Because since we don't know any of the side lengths to be congruent, it would be scalene. And we could also know that based off the angles, because congruent sides are opposite congruent angles. And congruent angles are opposite congruent sides. So number 1 would be acute scalene triangle. Are there any others on 1 through 6 we want to look at? Okay. Number 4. Well, number 4, we know all three sides are. So that would be lateral and equiangular. Really, if I'm given that all three sides are congruent, all three angles have to be as well. Because congruent angles are opposite congruent sides. And if all three sides are congruent, well, it's going to mean that all three angles are going to be congruent. And the vice versa as well, because if I just given a triangle where all three angles are congruent, then all three sides are going to have to be congruent as well. Does that make sense? So if it is equiangular, it has to be equilateral. And if it's equilateral, it has to be equiangular. They go together. Because for naming the angles, we have right, obtuse, acute, and equiangular. For naming the sides, we have scalene, isosceles, and equilateral. Classify the triangle by its angles and find the measure of angle 1. Is there one of these here for 7 through 12 that we want to look at? Number 7. So we know that two angles are what? 90 and... So this here is a right triangle. We know that automatically because it has one right angle. So if it is a right triangle, we can go on and classify it by its angles because it's going to be right. Now, we also know that all three of these angles are going to do what? They're going to add together to be. So I can say that we'll call this x. X plus 23 plus 90 is equal to. We can add 23 and 90, which would be 113 is equal to 180. Then we can subtract 113 from both sides. This will tell me that x is equal to or we say that the measure of angle 1 is 67 degrees. Any other questions on this here? We good with these so far? All right. Let's look at the next set. Find the measure of the exterior angle. 18. Okay, because I think it's just those two. So before we look at 18, can anybody tell me the answer to 17? It already gave us the measure of the exterior angle. Yep. Here, so the exterior angle, 18x plus 5 is equal to what? Is equal to the sum of the opposite two interior angles. The exterior angle is equal to the measure, the sum of the measure of the opposite two interior angles. Well, the first thing we can do is what? Combine like terms. Because -1 and 46 would be plus. Yeah. And that will tell us that is equal to 45. Subtract 5 from both sides. And x is equal to 40. And last but not least, we would divide both sides by 10. Tells us x is equal to, are we done? No, because it asked for the measure of the exterior angle, not the value of x. So what we have to do is we have to take our 18x plus 5, staying on this side, plug this x in for it. So that'd be 18 times 4 plus 5. 18 times 4 is? So the measure of the exterior angle is 77 degrees. So once we find the value of x for these here, we'll have to plug it back in. Now 13 and 14, we didn't have to plug it back in. Well, we could, but if you look at 13 and 14, the exterior angle is just x or it is just y. So if we plug it back in, we'll get the exact same number. Does that make sense? So on those, finding the value of x or y is the same as finding the exterior angle. Any other questions on 13 through 18? Are you good with those there? Let's look at 19 through 22. Find the measure of the acute angles. Which one of these do y'all want to look at? 22. Too far. How many answers are we going to have for these problems? Well, 3, yes. Because we'll have the value of x and then the two acute angles, yes? Now, we know that these 3 angles add up to be what? 180. We also know that what? The 2 acute angles add up to be 90. We could do it either way. Because we could set it equal to 90. If you don't remember that with right triangles, setting it equal to 180 will not make a difference. We will get the same values. Now at this point here, we can combine our like terms. So x and 3x is 14 and 1 is plus is equal to 90. Now to get x by itself, we would subtract 15 from both sides, which will tell us that 4x is equal to okay. Any questions on how we found the value of x? No? So 18.75. Now, we're going to take 3x plus 1, so we'll have 3 times 18.75 plus 1. Now, at this point here, I would just type that straight into the calculator. Because, I mean, we could do 3 times 18.75 and then add 1 to it. What would we? 57.25. Now, the other one is 0.75 plus 14, and this gives us, any questions on how we got these here? And what did we say these two angles add together to be? 5 and 5 is 0. Carry the 1. 1, 2, 3, 7 is 0. Carry the 1, yes? 7, 8, 9, 10 would be 0. Carry the 1. So we get back to 90, yes? So they work. They are the correct answers. Does that make sense? So one way we can check and make sure we do get the right answers if we add the two acute angles back together and they equal 90, it works. Or if we added all three angles together and equal 180, then we got the right answers. Questions on this here? If they don't and you're 100% sure you got the right answers, ask. Because that's how it's been with some of them. The last, I think one of the bonus with the vertical angles a few chapters back. The correct answers did not work in the actual problem. But I try to make sure that they do. Okay. Questions on 23 or 24? Which one of those y'all want to look at? 24. For these here, how many answers are we going to have? Because we've got how many sets of angles? How many sets of sides? And we need a congruency statement. So we've got 3 sets of sides, 3 sets of angles, and a congruency statement. That's 7 parts. Now, for this here, I believe that the triangles are set up like this here. Yep. Because I just didn't have it written in. Now, if we look at the angles, angle H would be congruent to angle what? B, yes? Angle J, C, and angle I would be congruent to angle A, because they all have the same number of marks inside the angle. Now we can say AB is congruent to what? HI. BC is congruent to. And lastly, AC or CA is congruent to IJ. For this here, make sure your angle markers, when you're talking about the angles, do have the angle marker. And the segments, the line segments, have our line segment marker. I'd hate to have to count off a half a point for not including those. Well, our last thing is our triangle congruency, yes? Does it matter how we label the first one? No? Give me one. HIJ is congruent to triangle. You can also do it by just matching up the angles. Because H went first, well, what's congruent to H? B. Then we have I, which is congruent to, and J is congruent to. See, we're just matching them up. Any questions on 24? We can look at these here for 25 through 30. And really 25 through 30 is just what is congruent in both triangles, solve for what we don't know. Now, have we learned any method for solving for missing side lengths of a triangle? I mean, we've done distance formulas, but we haven't really worked with the Pythagorean theorem yet. So do we have a real way to solve for missing sides? No. So most likely the ones that we're going to solve for is a missing angle. Now let's see what matches up. So A and D are congruent. So we know that. B and E. Exactly, C and F. So that tells me that angle E is 98 and C is, well, yes, AC would be 12, 1 and 2, so this DE is 10 and FE or EF is 15. Because if we look at the angle markers, well, DE is the side length between the angle with one marker and the angle with two, yes? So what side length in the other one is between the angle with 1 and 2? AB, which would be 10, yes? So that matches up. Well, the only side we're missing really is between 2 and 3. 2 and 3 would be 15. So I just matched the two up, yes? Any questions on how we match this up? Well, let's look at the questions. DE. Okay, well, I have it written down as 10. Angle E, 98, because it matched up. Angle C matched up with 32. We don't know what A is yet, but we can find it. EF, 15. AC was 12. Well, how many do I need to solve for? 1, yes, angle A. But I do know that all three angles in a triangle add up to B. So we can take 98 and 32 and add them together. Nope, it is 50. Did I write 60 on yours yesterday? Yeah, I don't know. I was thinking 120. Yeah, if something looks screwy, tell me. Cause questions on this here? Questions on 31 and 32. Which one? 31? So looking at this here, what matches up? Because H and L are congruent. I and M. And then O and K, yes? And it's asking us to find the values of X and Y, yes? Well, looking at this here, well, 3x plus 7 is equal to what? 140, because those are the two parts are congruent, yes? And the other one is that 2y is equal to? Now we just need to solve. So it's very similar to the ones we did previous, but now we're just trying to find X and Y. So over here, the first thing we can do is subtract 7 from both sides, which tells me that 3x is equal to divide by 3, and we'll get a very nice number. Not really, but because yeah, 3 goes into 13 4 times, which would be 12, which leaves us with 1, which goes into 13 4 times, which leaves us with 1, and we have got a remainder of 1/3, or 0.3 repeated. Well, if we solve the other one, well, the first thing we would do is exactly subtract 4 from both sides, which tells us 2y is equal to. Divide by 2, I hit the wrong one, which tells us y is equal to 8. Yeah, no, I had the dashed line on the other one, I never use it. What I meant to hit was questions on this here. Questions on the next one. So 32 would be the same. We would just need to find out, well, A would be 2y minus 50, and those 3 angles would add together to be 180. Oh, let's definitely look at next set. 31, oh well, not that one. These here. Determine whether there is enough information to say the 2 triangles are congruent. And if they are congruent, explain why and write the congruency statement. So if they are not congruent, what do we write? No, not congruent. Do we need anything else? No, because it only states, and if they are congruent, explain why, and put the congruency statement. So if it's yes, we've got multiple parts. If it's no, we just say no and move on. I will also say, if you put no on one that is yes, you'll still lose the points for not including everything else. Does that make sense? So, yes. So, why don't we list those out? I'll list those out because the ones that work are side, 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 angle, side, angle, side, angle, angle, side, or side, angle, angle. Now, there is hypotenuse leg if it is right, and that's only if it is a right triangle. I believe I pulled all of those out of the test. There's not going to be a hypotenuse leg. Don't work. Is angle, 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 or side, side, angle. Are the ones that don't work. Any questions on this here before we look at the first one? Okay. I take that back. There is one in there, but I will take either, if you notice it or not. Wake back up. So, looking at 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, or 45. Is there one of those in particular that y'all want to look at? 35? We have it right here. Is there enough information to say that these 2 triangles are congruent? Yes. I'd agree, yes. So we have side, angle, side, yes? So we know that is congruent to OQ, because there's our side. we have angle N is congruent to angle Q. And our other side would be is congruent to QP. Our side angle side. So we've explained it. Now we're missing what? The congruency statement. So L in M is congruent to triangle what? So L in M O Q P. Along the side with 1, our angle side with 2. Just make sure they follow the same path. Questions on this so far? Yeah. Let's look at 38. Is there enough information to say that these two triangles are congruent? No. Because how many sets of sides do we have? Do we have any angles? How many pieces do we need to just be able to say yes or no? 3. So if I have less than 3, it's an automatic no. 39's hiding down here. So 39, we do have this additional angle here, which is a vertical angle. So this here would be yes, side angle, angle, or angle, angle, side. I will take either. Now our angles is we do have angle A is congruent to angle E. Now we can't say angle C is congruent to angle C because there's more than one angle there. But I could call it angle ACF is congruent to angle DCE. And when we name it using 3 letters, the vertex, the point where that angle is at, should always be in the middle. And then the side that is congruent is congruent to line DE. So we can say triangle what? ACF is congruent to triangle ECD. And that's it. Questions on this here? So these here aren't overly, I wouldn't think too complicated. There's just several things that we need to list for them. Any other questions to 45? $41? Yes. And then we would list out all 4 sets of sides in our congruency statement. So we good with 41? We can do yeah. I don't think yours has this little box, does it? No, leave it off because it just means I didn't erase it here. If the little box is there, okay, I want white. But if this wasn't here, would we be able to say that these two triangles are congruent? No, not necessarily. This here would be no. Because we could say that these two angles are congruent in the triangle as a whole, but we have what? Angle side. angle side side is not one of the ways that works every single time. It only works if it is a right triangle. So this would be no. Questions on, we'll come back to 46 and 47 if we have time. I want to look at 48 through 52, the last set of problems, yes? Is there one of those in particular that y'all want to look at? 50? I'm trying to see if I can find. Okay, 50 does, I must have just missed it in the thing. So 50 looks like this here, yes? X, Y, Z, W. Triangle X, Y, W is congruent to triangle W, Y, Z. Is there enough information to say that these two triangles are congruent? Or not? Right. It's the wrong statement. No. Wrong statement. That's it. No, wrong statement. Now, A, B, C, E, D, C. Okay. The first 48, because I think there's two 48s. Can we say that these two, can we determine that these two triangles are congruent by the given statement? They do line up, yes? By what? That's all I want. That's all I want. Because they already gave us the congruency statement. We just said yes because of this. Can we say that the other 48 is true? Because E, F, G, H, K, no, wrong statement. Heck, that's an easy way to check it, isn't it? I just traced out the statement H, E, F, G, H, K, I. Well, heck, those don't match up already on the first line. These do, but it should have been going H, I, K. Any other questions on this here? Yep. Is 46 or 47, is there one of those that you all want to look at in particular? Now, 46 and 47 are working off the fact, or the properties of isosceles and equilateral and equiangular triangles. Since I know that these two angles are congruent, it means the two sides opposite them are congruent as well. Now, since one of the sides already has a single mark, I can just put a single mark on the other. So these two sides are congruent. Well, all except for really this side are going to be congruent to each other, yes? So 3y minus 18, our y plus 4, and our 2x minus 7 are all going to be congruent, yes? So what can we set the 3y minus 18 equal to? I'm not going to mess, I won't set it equal to 2x minus 2. because that's not going to make a whole lot of sense. Now, we can solve for the value of y by, I'm going to subtract y from both sides so that I keep the values of y positive. 3y minus y is minus 18 is equal to 4. Then what can we do? Add 18 to both sides. 2y is equal to 22. Last but not least, divided by 2, which tells me, well, we found one of them, yes? Well, if I plug it back in, what's 11 plus 4? Yes. Make sure, because the printer did not print that well. 46. 11. Yep, it is 7. I'll need to rewrite that on the master copy. Minus 7. So that that's easier to read. To both sides, which tells us 2x is equal to. Divide both sides by 2, and ironically enough, x is Questions on this here? Questions on 47? Why not? We've got time. Now, since these two angles are congruent, it means, well, this angle is 2x. It also means that these two side lengths have to be congruent. Now, I believe on yours I wrote in 20, yes? Well, it's really working off the fact that this angle up here is going to be 80. It's another isosceles triangle, yes? And the angles opposite congruent sides are congruent. Since one of them is 80, the other has to be 80, yes? What's 80 plus 80? 180 minus 160 is, so that angle is 20. Yes. Now, another way we can look at it is, isn't 80 here an exterior angle? What are the opposite two interior angles? So we could say that 80 is equal to 2x plus 2x, or really, yes, 4x is equal to 80, yes? We can divide both sides by 4. And then, well, we could plug it back in, and it won't work as well, because 40 and 40 would be too small. Because this would need to be bigger than 20. But with it as 20, yeah, I need to go back and redo this because that needs to be a bigger angle, or a smaller angle technically, for this to work out well. Does that make sense? Because 20 times 2 is 40, and this here would be 40 and 40 is, plus 20 is 100. So this needs to be bigger. Does that make sense? Because really this should be 100 for that to work. But it also means that that would be a straight line. Now for y, that's a little bit more straightforward because 3y minus 2 is equal to, add 2 to both sides, which tells me that 3y is equal to 31, yes. And then we would Y is equal to 10 and a. And most likely 46 and 47 are only going to show up as bonus. Any other questions on any of this here?